Dear children, today we will discuss about dimension of a physical world. What is meant by dimension of physical world? Okay? Dimension of physical world. In the last class already we discussed there are 7 fundamental quantities. Which are those 7 fundamental quantities? Length, mass, time, temperature, amount of substance, luminous intensity, and electric current. So these are the 7 fundamental quantities. So this can be considered as a 7-dimensional world. So whenever we are representing dimension, or if we are mentioning dimension, so we will write with a square bracket. Okay. So this will be read it as dimension of length. If that length is written in a square bracket, that will be read it as dimension of length. So the dimension of length it is written as this L. Similarly, dimension of mass is M, and dimension of time is T. Okay, and dimension of temperature, here again we cannot write T. No? For remaining the 4, the dimension is represented by its unit. So here temperature SI unit is Kelvin. So K. Again, amount of substance, its unit is mole. And luminous intensity, its dimension is CD, candela. And electric current, its dimension is A. Okay, so the first thing, length, mass, time, its dimension is represented by its first letter, capital letter in that square bracket, and remaining 4 quantities dimension is the unit. Okay, is it clear? So what is meant by dimension? So dimension of a physical quantity is the power, it is the power to which the fundamental quantities, power to which the fundamental quantities to be raised to represent it completely. To represent that physical quantity. Okay. So this is the fundamental. It is the power to which the fundamental quantities must be raised to represent that physical quantity completely. Okay, that is known as dimension. So what is the meaning of that? I will give you 1 or 2 examples. I have no need of by hearting this sentence as such. You should know. I will give some examples so you will come to know what is meant. So already this part is clear, no? Dimensions of 7 quantities we do. Now for example, if you want to find the dimension of speech. Dimension of speech. So, first you should know the relation or formula to find speed. What is meant by speed? Speed is equal to distance by time. No? So we can write distance divided by dimension of distance divided by dimension of time. And what's the dimension of distance? Distance means it is the length only, no? You can measure in millimeter, centimeter, kilometers, whatever it is, but that is the length. So here, what's the dimension of distance? Dimension of distance is L. Then dimension of time. What's the dimension of time? Dimension of time is, okay, so dimension of speed, how we can write? We can write it as L, and 1 by t can be written as t raised to minus 1. So we will get it as L t raised to minus 1. So this is the dimension of speed. Okay. And what about other fundamental quantities? Remaining all fundamental quantities are 0. So if you want, you can write like this also. Actually, dimension of speed is only, it has the power of L1 and t has the power minus 1, and remaining all quantities power is 0. So if you want, you can write like this also. M raised to 0, L t raised to minus 1, k raised to 0, a raised to 0, CD raised to 0, and mole raised to 0. Which means all other fundamental quantities power is 0 except length and time. That's why it is written. It is the power to which the fundamental quantities to be raised to represent it at particular physical quantity component. So here we are finding the dimension of speed. When you are finding the dimension of speed, you can see that you are getting only L t raised to minus 1. Why only L t raised to minus 1? Because speed is equal to distance travelled divided by time taken, and distance has the dimension of length and time has the dimension of time only. So you will get L t raised to minus 1. So remaining all powers is 0. So we can say that this is the dimension of speed. Is it clear? So some more examples we will discuss. Okay. So this thing you have to remember, okay? All these 7 fundamental quantities and how their dimension is represented. Based on that only, you can solve other questions. Is it clear? So now we will find the dimension of velocity. Dimension of velocity, okay? So we can write like this. Dimension of velocity. How to find? What is the formula to find velocity? Velocity is equal to displacement by time. No? So we can write dimension of displacement divided by dimension of, and what's the dimension of displacement? Again, displacement is the path length. No? It is the shortest distance between 2 points. So it is final position minus initial position. So that also will be, has the dimension of length only. So we can write L again by T. So what you will get? Here also you will get it as L 1 by T can be written as T raised to minus 1. So that is the dimension of velocity. So here you can see that velocity and speed both are having same dimension, L T raised to minus 1. Okay? Is it clear? Now we will discuss another one, acceleration. Dimension of acceleration. So what is meant by acceleration? Acceleration is equal to rate of change of velocity. No? So you have to write change in velocity divided by time. Change in velocity divided by time. And what's the dimension of change in velocity? Change in velocity will have a dimension of velocity only, no? If you subtract one velocity from another velocity, what you will get? You will get the unit of velocity only. So we can say, or we can write like this. Change in velocity has a dimension. What is the velocity has a dimension? L t raised to minus 1. So change in velocity will also have the same dimension. L t raised to minus 1 divided by t. Dimension L t raised to minus 1 by dimension t. Or we can write it as L t raised to minus 1 t raised to minus 1. Or this can be written as L t raised to minus 1. This is the dimension of acceleration. Okay, this is clear? And now we will find what's the dimension of force. What is the relation between force and some other quantity? You have studied in 9th standard. No? Force, according to Newton's third law of motion, you can write force is equal to mass into acceleration. No? So we can write force is equal to mass into acceleration. And what's the dimension of mass? Dimension of mass is m itself. And what's the dimension of acceleration? Just now we discussed dimension of acceleration is Lt raised to minus 2. So we can write it as m L T raised to minus 2. Is it clear? Now we will discuss dimension of momentum. So what is meant by momentum? Momentum is the product of mass and velocity. No? Momentum is equal to mass into velocity. Momentum is the product of mass and velocity. So dimension of momentum is equal to dimension of mass into dimension of velocity. Momentum we used to represent by the letter P. So if you want, you can write P also, no problem. Otherwise, momentum also you can write. Dimension of mass is m, and dimension of velocity. What's the dimension of velocity? It is Lt raised to minus 1. What you will get? Dimension of momentum is equal to m L T raised to minus 1. Which means other fundamental quantities power is 0. You can write, if you want, you can write a raised to 0, k raised to 0, cd raised to 0. All those other powers are 0. Okay. Is it clear? Understood now how to find the dimension of a physical quantity? So one thing you have to keep it in mind that whenever you are finding dimension, one thing you have to keep it in mind, you should know the relation. You should know the relation or how to find that physical quantity. That formula you should know. Without knowing that, you cannot find the dimension. Okay. So in 8th class, 9th class and 10th class, whichever physical quantity you have studied, its formula you can note down in one book. Okay, in that book. So that, and by using that formula, you can find the dimension of that each quantity. So some more examples we will discuss. Okay, 2-3 more examples we will discuss. Now, dimension of pressure. Dimension of pressure. So what is meant by pressure? Pressure is equal to thrust by area. Is equal to thrust by area. So what is the formula to find thrust? Thrust is the force only. So you can write dimension of force divided by dimension of area. Dimension of force already you know it is mLt raised to minus 2. Just now we have discussed it. Dimension of force is equal to mLt raised to minus 2. But what's the dimension of area? Area can be written as length into breadth. No? Whatever may be the shape. If it is square shape, in that case it will be side into side. It will be there. Okay. So if it is, but if you are considering a circular, this one, in that case area is equal to pi r square. Pi is constant, then also there it will be r into r comes. So one length into another length. So we can write dimension is area is equal to a square. Is it clear? Length into length it will be there. So that we will get it as L square. Okay. So here we can substitute. So we will get pressure, dimension of pressure is equal to dimension of force is m L T raised to minus 2 divided by L square. Or this can be written as m L T raised to minus 2 into L square. L square, if it comes to numerator, it will become L raised to minus 2. L raised to minus 2 and L raised to 1, it will become L raised to minus 1. How? A raised to m into a raised to n. No? Is equal to a raised to m plus n. Or a raised to m by n, by using that also you can find. Okay. So that you will get it as m l raised to minus 1 t raised to minus 1. Okay. M l raised to minus 1 t raised to minus 1. Is it clear? Now we can find the dimension of volume. Dimension of volume. How to find the dimension of volume? If you are considering a cuboid, this can be written as length into breadth into height. No? Length into breadth into height. All are having dimension of L only. So L into L. So that you will get it as L cube. So you may think that if it is a, instead of cuboid, if it is any other shape, what will happen? If it is cylindrical shape, what is the formula? Volume is equal to pi r square h. So here pi is constant, no need to worry about its dimension, it has no dimension. Then r, length r square will be length square into length. Again it has the dimension L cube. If it is another one, what it is cone, formula to find is 1 by 3 pi r square h. Again you are getting that same L cube, it will be there. If it is of sphere, the volume is given by 4 by 3 pi r cube. So here this part is constant. Again you can see that r cube, length cube will be there. So whatever may be the shape, not a matter, dimension of volume will remain same. It will be L cube. Is it clear? Okay. Now we can find dimension of density. What is the dimension of density? Then what is the formula to find density? Density can be written as mass by volume. Mass divided by volume. So dimension of mass, what's the dimension of mass? It is m, and the dimension of volume is L cube. So m by L cube, or this can be written as m L raised to minus 3. The dimension of density. Okay. Is it clear? So similarly, you can find dimension of other quantities, some more related to electrostatics. Also, we will discuss some dimensions. Remaining dimensions in textbook it is given. So many physical quantities dimensions are given. You simply don't write that in notebook. You have to get that relation. Only formula you can write that. By using that formula, you have to find the dimension of that particular physical quantity if you don't know that formula. Okay. Otherwise, if you remember the formula, no need of saying that table only, directly you can write it. Otherwise, at least you can write that physical quantity, then you write the formula. By using that formula, you find the dimension. Okay. Now, we will discuss the dimension of charge. Dimension of charge. So, what is the relation between charge and current? Current is the fundamental quantity. So, we know that current is equal to charge by time. Current is equal to charge by time. So, charge can be written as charge is equal to current into time. Current is equal to charge by time, that is the formula. So by using that we can write charge is equal to current into time. Now you can find the dimension, no? So dimension of charge is equal to, what's the dimension of current? It is not C, that you have to keep it in mind. It has a dimension A. And what's the dimension of time? Please. So what you will get? You can write it as A into. Okay. Is it clear? Understood? Now you can find the dimension of potential difference. dimension of potential difference. You can write it here, potential difference. So what is the formula to find potential difference? Potential difference is equal to work done divided by charge. No? Work by charge. Work by charge. And what is the formula to find work? Work is equal to force into displacement. Work is equal to force into displacement. So dimension of work can be written as dimension of force into dimension of displacement. Okay. Or we can write it as dimension of force is, just we discussed, it is ml t raised to minus 2. Those who are having doubt, you can just pause and you can check earlier. Okay, just we discussed ml t raised to minus 2 and dimension of displacement is L. So we will get it as m L into L. This will be L square, m L square t raised to minus 2. Okay, so we can write m L square t raised to minus 2 divided by charge. This charge A into. Okay, so what you will get? M L square t raised to minus 2. This will become t raised to minus 3 and a raised to minus 2. M L square t raised to minus 3 a raised to minus 1. That is the dimension of potential difference. Okay. Now you can find the dimension of resistance. How to find the dimension of resistance? How to find the dimension of resistance? Resistance is equal to potential difference, no? By using Ohm's law, V is equal to I into R. So R is equal to V by I. No? You can write it as potential difference by current. So you can write V divided by current. Okay. And what's the dimension of V? Already you have written ml square t raised to minus 3 a raised to minus 1 divided by current. Current has the dimension V itself. So that you will get it as ml square t raised to minus 3 a raised to minus 2. This will go to numerator, so that you will get it as ml square t raised to minus 3 a raised to minus 2. That's the dimension of resistance. Okay. Is it clear? Okay. Now some more quantities dimension we will discuss. You can find the dimension of energy and those things. Okay, that will give. Okay, as question and give so to find the dimension of some quantities. So now we will discuss to find the dimension of angle. What is the how to find angle? You have studied. If you are considering an arc with this arc length and this is angle and this is radius. You know that angle is equal to arc length divided by radius. Angle is equal to arc length divided by radius. So what will be the dimension? Arc length has dimension L and radius has dimension L. So that you will get it as L raised to 0, which means it has no dimension. Okay, m raised to all quantities dimension is 0. It has no dimension. Okay, this is one of the example of a quantity which has no dimension. It is a variable but it has no dimension. Similarly, angular velocity. All these you will study in the coming. So these things you will study in the coming chapters. Okay. So now at least just for the how to find the dimension, for that only I am writing the formula. Later on in the coming chapters you will see all these formulas. Okay. So angular velocity is equal to angular displacement angular velocity is equal to angular displacement by time. Angular displacement means angle covered. No? Angular displacement is equal to angle covered. So we can write angle by time only. And dimension, angle has no dimension. So you can write 1 divided by time has dimension 3. So you will get it as a raised to minus 1. That is the dimension of angular velocity. Okay. Same way it is angular acceleration. Angular acceleration. So angular acceleration equal to change in angular velocity by time. Similar to normal acceleration. Normal acceleration we can write it as change in velocity by time taken. So here change in angular velocity by time taken. Okay. So we can write change in angular velocity. Change in angular velocity divided by time taken. And what is change in angular velocity? It has a dimension of angular velocity only. What's the dimension of angular velocity? It is t raised to minus 1. So t raised to minus 1 divided by time taken is t. So we will take it as t raised to minus 2. That is the dimension of angular velocity. Okay. 3 more physical quantities that we will discuss now. And after that we will wind up the class. And next one is stress. This is not the normal stress. Normally now you are under stress of dimension. This is not that stress. Stress is related to elasticity, and it is the relation for stress is given by stress equal to force by area. Stress is equal to force divided by area. So what's the dimension of force? Dimension of force is given by m L raised to minus 2, and dimension of area is L square. So that we will get it as m L raised to minus 1 t raised to minus 2. So here you can see that this stress has the same dimension as that of pressure. Okay, is it clear? Next, another quantity is known as linear strain. Okay. Linear strain. Any strain. Okay. Linear strain is equal to change in length. Formula is that change in length divided by original length. Linear strain formula is change in length divided by original length. So how to find the dimension? So this will be again L divided by L, which means it has no dimension. Okay, this is another example of a quantity which has no dimension. One is angle and another one is strain. So if it is volume strain, what you have to write? Change in volume divided by original volume. That case also it has no dimension. So any strain will not have any dimension. Okay, is it clear? Next one is modulus of elasticity. Modulus of elasticity. So modulus of elasticity means stress divided by strain. Stress by strain. So you may wonder that from where we are getting this formula. All these formulae are there in one or other chapter 11th only, except electrostatics and magnetism. Remaining all formulae related to mechanics, all those formulae will come in one or other chapter. Okay. So modulus of elasticity is equal to stress by strain, and the formula, dimensional formula of stress is m e raised to minus 1, e raised to minus 2, and strain has no formula because it is a dimensionless quantity, so we will get like this. Okay, is it clear? Now, next one is torque. Torque is given by force into perpendicular distance. Okay, force into perpendicular distance, that is known as torque. So dimensional formula of torque is equal to dimensional formula of force into dimensional formula of perpendicular distance. So what's the dimensional formula of force? It is given by ml e raised to minus 2 into perpendicular distance is distance only, no? Whether it is perpendicular distance or parallel distance, distance will be distance only, it has a dimension of L only. So ml e raised to minus 2 into L, so that you will get it as L square e raised to minus 2. Okay, so this is another example. You can see that here torque and work. Work already we discussed, work is equal to force into displacement. So here we can say that force and torque has the same dimension. Is it clear? So similarly, in the same way you can find the dimension of various physical quantities. Already in textbook various physical quantities are there. Each quantity you can write, and if you know the formula, better without seeing that only you can find the dimension, and if you don't know the formula, you refer that formula, and by using that formula you can find the dimension of that physical quantity. Okay, and you may think that why we have to study these things, and these applications of these dimensions that we will discuss tomorrow. Okay, thank you.